Okay, hello everybody and welcome to this club's meeting. In our meeting today, we'll be covering the topic of breadth first search, or BFS as it's commonly called. And this is a type of algorithm used for traveling through a space, such as a graph, a grid, and it visits the nodes or every single square in a particular order. And that's what we'll be learning about today. So just let me know if you can see my screen.
We can see it.
Okay, cool. So I'll start presenting. Yeah, so today we'll be talking about breadth first search over here. And our agenda for this meeting is we're going to talk about what BFS is, how it works. We'll take a look at some pseudocode and examples, and then we'll actually code it ourselves along with the flood fill algorithm. And we'll take a look at shortest path and we'll code a maze problem, the solution to a maze problem. But before we get started, we're going to take a look at this nice picture over here. So over here, we have a water droplet falling into a pond. And there's a reason I chose this diagram or this picture because it's helpful in understanding how a BFS works. So you can see that we have this water droplet, it's falling into the center of the pond. It's falling into the center of the pond over here. And what do you see coming out from the center of the pond as a result of the water drop hitting the pond?
A ripple.
Yeah, we see ripples. And what shape do they take?
Circles.
Yeah, they're in the form of circles. And which direction do they move? Do they move inwards towards where the water droplet hit? Do they move outwards? How do they move?
Outwards.
Yes, it moves outwards. So this is kind of how a breadth first search works. When you have a grid and you're given a starting point, what the BFS algorithm does is it moves outward from that point and it visits other points based on how far they are. So first, for example, it will start at a location that is one step away from where in this example, the water drop hit the pond. So it'll start over here and it will visit all squares in this vicinity. And the next step, it will expand outwards, just like a water drop. And the BFS algorithm will go to the squares another step further, so 2 steps away from the starting point. And it will keep on moving outwards until it's gone through all the squares. So I hope this analogy made sense to people. And now we'll be taking a look at the steps that BFS follows in general. So first we start at a point in the grid, and typically in competitive programming problems, this point is given to you. Then we expand outwards from that point. So we start by expanding one level out. So one step out from our starting point, we go to all squares in that area. And then we go 2 or more levels out. Then we start expanding out even further. We go 2 steps away, 3 steps away, 4, and so on. Kind of like the ripples example we just looked at earlier. So here's a visual demonstration of what this would look like. We have this point in the grid that we're starting at, this square over here. From this point, our algorithm is going to expand outwards to these other 8 squares. And you can see all 8 squares are just one step away. Just like in the ripple, they all neighbor the starting point. And then we move out to the squares that are 2 steps away. And if there were more squares in this grid, you would keep on moving out and outwards until you've gone to all the squares in the grid. So the question is, how do we code this? And if you were here for last week's meeting, we talked about queues towards the end of the meeting. And the reason we want to use queues for coding this is because they give us fast insertion. Just a second. It's lagging a bit. Yeah, it gives us fast insertion to the end of the queue, and we can also do fast deletion from the front. And that's all we need. So the reason we're going to be using a queue for this is because we want to keep track of which squares we have to go to next. We can't magically go to multiple squares at the same time. So for example, if the ripple falls in the pond, we can't go to all squares surrounding that ripple at the same time. We have to visit them one by one. And we do this through a while loop and a queue. So what we do is the way the algorithm works is we add the starting point to the queue. So over here, you can just see I have it numbered. So the starting point is 3, 3. We add this to the queue, and then we add the coordinates to the queue of the square that we're currently at. And then what we do is once we've added 3, 3 to the queue, we go through and add all the squares that are next to it. So you can see these purple squares here are next to 3, 3. So we add them onto the queue. And adding squares onto the queue means that we have to go to them next. So you can see here we have 2, 2, 2, 3, 2, 4. This is what our queue looks like. It contains all 9 of these squares. And pay attention to the order. You can see that 3, 3, which we started at, is at the front of the queue. And all these other things that we just added are towards the end. So when something's at the front of the queue, that's the same as we can say that we're visiting that square. And by visiting a square, I mean that we're currently at that square and we're adding all stuff next to it. So that's what we did in this step over here. First, we added 3, 3, and then we added all the stuff next to it over to our queue. And now that we've finished visiting square 3, 3, we've added all the stuff next to it. We're expanding outwards. We don't want to keep 3, 3 in our queue. We're done with it. We're expanding outwards and we don't need to come back to it again. So that's why we're going to remove 3, 3 from our queue. And now if you look at the queue, all it contains are coordinates or squares that are one step or one level away from our starting point. So the only squares that are inside of our queue are these light purple ones over here, 2, 2, 2, 3, 2, 4, 3, 2, so on, up to 4, 4. They're all one step or one level away. And then we continue throughout our algorithm and we keep on adding for each thing at the top. So over here, 2, 2, we add all the stuff next to it. So if you look at 2, 2, and you look at what's next to it, you see these pink squares over here, these 5 pink squares. These 5 pink squares will also get added to our queue. And then 2, 2 would get removed. And eventually, you can see from the queue that the order of the elements are in a specific order. You can see that the stuff in this purple box over here, they're all one step away from the starting point. They're these purple squares over here, these light purple ones. And the stuff at the end of the queue, at the very end, there's stuff that was 2 steps away from the starting point. They're these light pink ones over here that are further away from the center. So this is how the algorithm works. It keeps track of which squares we have to go to next. And then it takes the element at the top, it takes the square at the top of the queue and adds all the stuff next to that. And it keeps on going outwards until there are no more squares left to add. Are there any questions about this?
Wait, so for the queue, would it delete all that stuff in the pink, and then it would be replaced by the stuff in the blue box?
Yes, that's correct. I wanted to demonstrate, how do I turn off the pointer?
Okay.
I just wanted to demonstrate how the queue stores stuff based on distance from the center. So you're correct. The stuff in the pink box would be removed, and then the stuff in the blue box would be there.
Okay. Also, for like some of the problems, they require you to know like the shortest distance.
Mhm.
So how would you like add like some sort of like thing to keep track of like the distance from the original starting point?
Yeah, that's a good question. You would have a 2D array for that. That's gonna be the third example we're going to be coding today. We'll take a look at it. And the nice thing about BFS is that once you understand it and you've got some experience coding it, it's fairly easy to code. And then BFS problems, grid problems, they just really require like maybe 1 or 2 lines of modification for you to solve the problem. Because once you know the basic code, you just have to modify it a bit based on what the problem's asking you to do. And now that are there any other questions? Those are good questions.
I'm guessing that's also going to prevent things happening from like when you're 1 away um, from you accidentally adding 3, 3 back.
Yeah, yeah, that's a good question. So are you asking like when you're at 3, 3, and then let's say you add these purple squares, and now you're the purple square, how do you avoid adding 3, 3?
Yeah.
Yeah, that's a good question. We do that through a Boolean array, and that it's a Boolean 2D array, and it just keeps track of whether we've been to a square. And we'll also be taking a look at that in the code. Okay, so now that everybody understands it, let's code it.